Good morning, good afternoon from San Francisco. We're going to give it a few more seconds here as we let some more people join the webinar. Thank you for joining us today. I hope the weather is also good by all of you. Currently, it's nice and sunny here in San Francisco. Give it just a few more seconds. Good morning, everyone. Thank you for joining us. We'll be starting in just a few moments. I see in Hamburg it's cloudy and 19 degrees Celsius. Wow, warmer than it is over here, I think. I'm very jealous. Give it just a few more moments. All right, I'll start now. Good morning, everyone. My name is Preston Locker, and I am pleased to welcome you to the Green Hydrogen Life Cycle Virtual Conference, the first of two of our events this week, brought to you by the representative of German business, GACC West. We are currently hosting a virtual green hydrogen Power-to-X delegation this week for companies in the renewable space, and on the occasion of their visit have organized this week's activities, including today's conference. The German Federal Ministry for Economic Affairs and Climate Action has funded this delegation through the Export Initiative, helping companies in the energy sector, especially in the fields of renewable energy, energy efficiency, smart grids, and storage technologies to enter foreign markets. We would like to thank the German Federal Ministry for their continued support. Now, I'd like to thank our extraordinary partners for this event: the German Federal Ministry for Economic Affairs and Climate Action, the Consulate General of the Federal Republic of Germany of San Francisco, Mittelstand Global and Export Initiative, RENAC, the Renewables Academy, the Renewable Hydrogen Alliance, eFuel Alliance, the California Fuel Cell Partnership, the German Chamber of Industry and Commerce of Stade, the German Chamber of Industry and Commerce of Kiel. I invite you to join me for the next 2 hours to gain rare industry insights from the public and private sectors, where experts address the future of hydrogen as a renewable, use cases, and transatlantic cooperation potentials. Today, we will feature 2 keynotes from both sides of the Atlantic, highlighting where we currently stand and what the future holds, presentations from 4 of our German delegation members, including Dietering & Partner, Enapter, Engineering Office Hoffmann, and SMA, followed by a panel discussion about how California and Germany can best move forward with green hydrogen and Power-to-X solutions. But before we get started, I'd like to hand it over to German Consul General Oliver Schramm, who will say a few welcome words. Welcome, Mr. Consul General, and thank you for taking the time to meet with us today.
Thank you very much, Preston. Good morning, everyone. Thank you for having me. I applaud the GACC West for their initiative. It's an impressive field and roster of speakers and experts you have put together, and I would especially applaud the keynote speakers Janice, Lynn, and Franz Leona on what I expect are going to be eye-opening and very instructive contributions to a discussion and debate that couldn't be more to the point as we are living into the 76th day of war in Ukraine, which is of course highlighting and underscoring the necessity for an ever more sped up energy transition, and certainly hydrogen which is of course not a new concept. I've looked up the first visions came from back in the 19th century. Jules Verne, actually, the French author, wrote in one of his books about water being the coal of the future. But of course, hydrogen today is a reinvigorated concept, and the one that is, of course, so much needed in the future. The accelerated expansion of hydrogen supply chain is key to the transition to sustainable energy. Green hydrogen plays a key role for the transformation of our economies, of the German, the US economy in the future. We will need large amounts of green hydrogen. This will also include imports in addition to hydrogen being produced on the spot, be it in Germany or in the US. Germany wishes to further speed up the transition from conventional natural gas to green hydrogen. In the context of our national hydrogen strategy, as part of our decarbonization campaign, we want to create a demand for clean hydrogen totaling up to 3 million tons per year by 2030, with the bulk, of course, being imported. Demand is expected to increase to more than 11 million tons per year then by the year 2050. And the German National Hydrogen Strategy was adopted by the German federal government on June the 10th, 2020. And as a background, the Paris Climate Agreement in Germany has committed itself to ambitious climate targets in the Paris Climate Agreement, beg your pardon. In order to achieve these targets, it will require electricity-based energy sources. And from the German perspective, only so-called green hydrogen will be sustainable in the long term. However, we assume that due to lower costs and other forms of CO2 neutral hydrogen, such as blue hydrogen, will play an important role during a transitional period of time. So it's a gradual process we have embarked on. Number one, the first step that needs to be taken to accelerate the rollout of hydrogen technology will be the creation of a strong domestic market for the production and the use of hydrogen. But besides the domestic market, international markets will play an important role as well. Because of this market-driven approach, the objective to make hydrogen competitive is at the center of our efforts. So secondly, the key element of the German hydrogen strategy is a so-called national action plan that consists of 38 measures. And don't worry, I don't want to go into every detail of these measures, but let me sum up their key principles. So one, they address the complete value chain from production to infrastructure to fields of application. Secondly, they aim at stimulating the demand for hydrogen or at reducing costs for hydrogen. And then thirdly, the focus lies in the short term on those areas where there are no other ways to decarbonize or where the use of hydrogen is, compared to other alternatives to decarbonize, closest to economic viability. A particular focus is being placed on areas where the use of hydrogen is already close to commercial viability or which cannot be decarbonized in other ways. This is the case for certain industrial branches and in certain parts of the transport sector, especially heavy-duty vehicles, maritime transports, and others. This being said, in the long run, hydrogen might also play an important role in other areas, such as the heating market. Finally, allow me some brief remarks on international aspects of hydrogen. Germany has been and will be dependent on energy imports. Germany is currently working rapidly to reduce its dependence on Russian energy, I've alluded to that, and to broaden the supply base of its energy. Thanks to intensive efforts with all the relevant stakeholders, it has been possible to make significant progress in that process, to diversify the supply chains and thus to achieve clear reductions in the degree of dependence. But of course, as you all know, there's more to come and more to do. Therefore, international cooperation and trade are important elements of our hydrogen strategy. The German government invests heavily in international cooperation, and hydrogen plays an important role in Germany's bilateral energy partnerships. For instance, hydrogen was one of the main topics at the last California-Germany bilateral energy conference that took place in December of last year. And there are many promising projects going on right now. For instance, here in the Bay Area, I'm thinking of the hydrogen-powered ferry that has started its service recently, as is going on in Germany, and we'll learn about it a little later. So it's great and timely, I think, that the GACC West has put together such a great roster of expert speakers in the field, and I'm looking forward to what I think will be a very instructive conference. Thank you for your attention and all the best.
Thank you, Mr. Consul General, for your welcome remarks and taking the time to further highlight this important issue. Now it's time for our first keynote. Janice Lynn is the founder and chief executive officer at Stratogen, where she has distinguished herself as a leading clean energy changemaker and visionary. She brings more than 2 decades of experience in clean energy market development and corporate strategy to the role. Janice founded and serves as president of the Green Hydrogen Coalition, an educational nonprofit dedicated to advancing the production and use of green hydrogen in all sectors, where it will accelerate the transition to a carbon-free energy system. Please welcome with me, Janice Lynn.
Thank you, Preston. I am so happy to join you all today. I'd like to also thank Mirko, the GACC, of course, the Consul General, for his inspirational remarks. It's amazing what Germany is doing to drive multi-sectoral decarbonization and greater energy security. And of course, the German Federal Ministry. It's such an honor and privilege to be invited to speak about green hydrogen at an event hosted by the German government. And particularly since my hydrogen story started with a visit from Dr. Michael Starner, a Fraunhofer scientist, in 2010. Now in 2010, at that time, I was just launching the California Energy Storage Alliance and trying to overcome a literal wall of utility opposition against innovative new uses of energy storage in the power sector. I was kind of busy. And Dr. Starner, who was in the Bay Area, generously visited my office in 2010 and shared the most fantastical vision I'd ever heard in clean energy since I started my career. He called it Power to X. He described a future vision where we would produce green hydrogen from water, wind, and solar. He described a vision where someday Europe's natural gas pipeline would be converted to moving not natural gas, but green hydrogen. And that with this abundant low-cost green hydrogen, we would decarbonize multiple sectors, including producing synthetic fuels that would someday power airplanes. Now, this was 2010, and I remember when he left my office, I was thinking to myself, that is a big vision. You know what? It is never gonna happen. Moral of this story, when a German scientist visits your office, you should pay very close attention because they are soothsayers. Truth be told, in 2010, hydrogen had already been a topic of the media and a focus area for California for some years, beginning with the Schwarzenegger administration. During this time and until now, California has made world-leading progress on hydrogen as an alternative transportation fuel, deploying more hydrogen fueling stations than any other state in the United States. Since then, as shown by this slide, the lens has widened. Dr. Starner's vision has now come true. Power to X is here. We're looking broadly, not just at transportation applications, but multi-sectoral decarbonization. Even Airbus has announced their intention to fully decarbonize flight and introduce hydrogen-fueled planes. I believe it was early last year that Germany closed the financing for its first green hydrogen pipeline, and earlier this year, our gas company, Southern California Gas, the largest gas company in North America, announced its intention to build the nation's first green hydrogen pipeline, Angeles Link. For me, along this journey, I didn't revisit the green hydrogen topic until 2016. And this was the model that got me there. At this time, I was still serving as the executive director of the California Energy Storage Alliance, and we asked a very simple question, which was, what kind of storage will we need here in California when we achieve 80, 90, 100% renewable penetration? We did a simple model which advanced the amount of intermittent renewable generation because it's the cheapest at the margin, so that all demand would be met by wind and solar, and plotted the result. And this chart shows the daily deficits or daily surpluses over the course of a year. And after looking at this slide for about 10 seconds, in 2016, I came to the conclusion we were going to need some serious long duration storage. And this type of storage is not something that pumped hydro, underground compressed air could meet. We're talking multiple days, monthly storage, ultimately seasonal energy storage. Then in my research, I kind of followed in the footsteps of Dr. Starner and learned everything that he already knew way back in 2010, that hydrogen was a mature commodity, that the cost of producing green hydrogen would dramatically fall with scale, and that you could use green hydrogen to decarbonize just about every sector. Some years later, this was 2016, after learning all this, I decided that this really powerful, little abundant molecule made from renewable sources was the key to a more sustainable future for our planet. And I did what every inspired person does. I went out and started a new nonprofit called the Green Hydrogen Coalition. We formally launched the GHC in 2019 as a 501c3 educational nonprofit whose mission is to accelerate a green hydrogen economy. But we're doing it with a little twist, because as you know, there are many nonprofits focused on hydrogen. One, we're solely focused on green hydrogen. Secondly, we have a thesis that the way to accelerate progress is to simultaneously scale both supply and demand. And we can't, hey, since 2010 till today, the urgency is upon us to go faster. We have to move faster to curb emissions and stop climate change. The rate of climate disaster happening around the world is only accelerating. And as noted by the Consul General, the imperative to have even more diverse sources of energy is upon us. So the question is, how do we compress this timeline? All analysts agree that green hydrogen will be lowest cost in the future. Some say 2040, 2045, 2050. We need to accelerate that reality to something like 2030. This is what the Green Hydrogen Coalition is up to. Our strategy for building momentum to achieve a cost-effective market situation is to drive market design while we're also driving commercial project development. So we have three main activities: market design and regulatory innovation. We're working closely with all the agencies here in California and regionally through the Western Green Hydrogen Initiative. This is an activity we started in partnership with the National Association of State Energy Officials and the Western Interstate Energy Board. It's a collaboration of 14 states, 2 Canadian provinces shown in green, specifically to advance green hydrogen infrastructure development. And then lastly, consistent with our original idea, we launched the HyDeal North America platform, following from a great case study of HyDeal ambition in Europe. And our very first green hydrogen hub is called HyDeal Los Angeles. This idea to simultaneously scale supply and demand so we can have visibility into really large scale demand across sectors, plan a high volume, competitive supply chain to achieve low delivered cost. Meanwhile, Germany is showing us the way forward. Thank you. I love this recently announced project between Fortescue Future Industries and E.ON. First of all, it's exemplary of what's possible and how hydrogen, green hydrogen, will soon be a traded commodity like oil and gas. It's also exemplary in what green hydrogen can deliver in terms of energy security and displacing large volumes of fossil fuels in a very short period of time. It's also a harbinger of a more sustainable global energy future. Move over oil and gas conglomerates. Here comes green hydrogen. Germany and California have been long-time clean energy leaders and collaborators innovating on how to accelerate change. I feel like Germany and California are kindred spirits. As noted, there's been a long-time collaboration on energy transition between Germany and California for many years. I would say the two locations, I think of California as sort of a nation state, has had profound impacts in the renewable energy world, also for the rest of the world. Green hydrogen is next up, building on this long history of collaboration. The question is, what can be the nature of this collaboration? And as we launch into the next 2 hours, I want to remind everybody that the pathway to accelerated progress lies in a compelling value proposition, the ability to maximize, recognize, and be compensated for all the benefits that green hydrogen can deliver, and of course, cost reduction. And there's so much innovation and collaboration that's possible on both sides of this scale. We know cost is going to come down, even by scale economies alone, but there's tremendous innovation, and I know of companies, even on this call, that can accelerate that further. On the benefit side of the equation, we need to make sure that we have the right market design and structure. There's tremendous innovation on the policy and regulatory side. If we want green hydrogen to be a globally traded commodity, it's important that we work from a common global framework. And that could include a common framework around carbon intensity, around tracking and retiring the renewable attributes associated with green hydrogen, and of course, sharing best practices for policies and programs for how do we compensate for all these benefits. There's also huge opportunity to collaborate on the cost side. There's lots of innovation on the production side, but I especially want to call out opportunities for collaboration on the infrastructure side. If there's one thing that we have learned in all our work to date, and I think Germany has shown us the way, is that infrastructure really matters to achieving low delivered cost. And that infrastructure can be domestic in how we move around hydrogen and pipelines and other infrastructure, but it can also include sharing best practices for how to import and export green hydrogen. So remember, ultimately, green hydrogen will be one of the world's most traded global commodities. I'll just wrap up my opening remarks with an invitation to collaborate. We have been busy for the last 2 years working on our first green hydrogen hub at scale called HyDeal Los Angeles. And our goal is to transform Southern California to be the first region in North America to achieve 100% renewable electricity affordably and reliably, to decarbonize fuels and move to liquid e-fuels, provide green ammonia or other synthetic fuels to maritime goods movement, potentially for fertilizer production. Remember, we're a big ag state. Demonstrate green hydrogen fuel cell passenger flight, and ultimately export low-cost green hydrogen at scale. And I'll finish with one of my favorite quotes from a famous social anthropologist, Margaret Mead. Never doubt that a small group of committed, thoughtful citizens can change the world. Indeed, it's the only thing that ever has. Thank you, and I look forward to the conversation.
Thank you, Janice, for your insightful keynote and giving us the inspiration of what the future for California holds. You mentioned, just quickly, one question maybe for yourself. You mentioned the first steps that need to be taken for HyDeal LA to happen. What is the most pressing technology that you see a need for at the moment?
On the technology side, there's so many. Boy, I don't even know where to start, because what we need is technology at every part of the value chain. And that's a message that we, as the Consul General mentioned, it's not enough to focus on any one corner of the economy. We have to simultaneously advance production, storage, transport, and also the infrastructure for delivery. So boy, we have needs across the board, but the good news is in our models, we just looked at commercially available technology at every step of those value chains. And it's
Okay.
entirely possible to get to under $2 per kilogram delivered. For California, we don't have salt caverns here in the state of California. And the location of geologic large-scale storage is a really big game changer in the final economics. So if I would pick one new technology, it would be, let's figure out how to repurpose natural gas caverns and retired oil wells.
Fantastic. Thank you so much for sharing. We'll be on the lookout for that technology and send it your way when we find it.
Thank you.
All right, and to represent a German perspective, we have our second keynote speaker. Franz Leona leads the International Cooperation Division at Germany's national organization Hydrogen and Fuel Cell Technology, which takes on assignments from the German federal government in the areas of sustainable mobility and energy supply. Franz was previously managing consultant at the international energy transition consulting firm E4 Tech. For almost 10 years, he helped clients navigate the interface between technology, policy, and business in the fields of hydrogen, fuel cells, and power-to-X technologies. Thank you, Franz, for joining us today.
Thank you very much, Preston, for this kind introduction. I hope you can see my slides.
We do, yes, thank you.
Perfect. Thank you. Yeah, thank you for the invitation. I'm really honored to be here today. And also, Janice, thank you very much for your keynote and setting the scene. I'd actually like to start with also a big picture view on the role of hydrogen in a net zero future for our planet, and then introduce you the activities of NOW, the National Organization of Hydrogen and Fuel Cell Technology in Germany, where I'm leading the international activities, and then a few updates on policy developments in Germany. So on the big picture, I think we can, with certainty, say today we live in the age of low-cost renewable energy, and that is something I think we have not seen coming 20 or 25 years ago. And that has changed the energy discussion fundamentally, because no longer is energy the actual problem, but time has become the problem, because time is running out to reach the Paris Agreement, to keep the climate crisis to a minimum, so to say. And so now we have low-cost energy available, but the problem is we have built our energy system on fossil fuels because they used to be cheaper. But for new projects, we can now use renewables as the cheapest solution, and that is exactly what Germany is planning. But also on a global scale, I think it is can be said with full certainty that renewable energy is probably the best chance we have to still get to a 1.5-degree scenario by 2050. Because we have seen in the last 20 years how quickly we can scale up solar and wind, and it's essential how we continue this growth to 2030. So we really need to further speed up and stay on this exponential growth trajectory, around 20% plus per year of solar and wind power generation combined. And that could put us on a track to reach the targets. I'm saying this also because there's this kind of debate that we have to do all kinds of options, including nuclear. And this was also a question just posted in the chat. You see the nuclear development over the recent decades globally here. And you can have any opinion about nuclear as you wish, but it's just clear that it will be too little too late to solve the challenges we have in front of us until 2050. Whatever will be after is, I think, a different debate. And also like to reemphasize what Janice said, we have the technologies that can get us to low carbon energies, also with hydrogen. We just have to get started, as we did 20 years ago with solar and PV, to really ramp this up. We have to ramp it up now with electrolysis and the production of green hydrogen to get the costs down. The technologies have been known and understood for a long time, but of course they have to be further optimized, and there's a lot of R&D potential there. but that should not stop us from acting now. Yeah, we have built our energy system based on fossil fuels. So today, that's the same situation globally, roughly as it is in Germany. We use 80% fossil fuels in the form of molecules then in our end users, and only 20% of electrons. And the academic solution would be now to try to change the demand side to full electric use as much as possible, because we now get on the supply side increasingly electrons from solar and wind. But then the challenge in this transition is that we now really have to focus on those options that are fast deployable, so to say. And I think it's a legitimate question to prioritize those measures that are fast to deploy. Just think of how to transition the entire residential sector, building, heating, to heat pumps that can run on electricity, and then also the power grid that has to accommodate this winter load, for example, in Germany, is a process that will take time. And we can't really expect that we'll have done this transition within a few decades. This is a lengthy process. We've seen in the past that on the demand side, measures are slower to be implemented than on the supply side. So my argument here would be to focus on solar and wind to really scale up the supply side, continue work on the demand side as well, but make just sure that we have enough clean energy available as quickly as possible. This then also requires huge amounts of storage, especially in also our climate in Germany. We face the same problem that batteries are not a solution for annual energy storage. You would have essentially one cycle, charge and discharge, because in a battery, the storage capacity and the power density that you can use are coupled, whereas in hydrogen, you can decouple that, especially with underground storage. That's a relatively low-cost way of storing huge amounts of energy. And then the generation and the use of hydrogen are separate from that storage capacity. In Germany as well, we have to repurpose or refurbish our power generation capacity to allow for hydrogen use to fill the gaps between the wind and solar generation. And now with the war in Ukraine, we want to speed up the transition away from natural gas, which could also mean that for some more years than initially was planned, we would use more coal, but then instead of using natural gas as a bridging technology, would directly be able then to switch to low carbon renewable solutions, and thereby in the long run have the same or even lower emissions in balance. What I'd like to really emphasize here is if we acknowledge that the challenge is to replace fossil fuels in all those large use sectors, industrial uses, we anyway have to make sure that green hydrogen becomes really low cost. To be a bit provocative, has to get dirt cheap, as cheap as fossils are today, essentially. Otherwise, we can't run those industries in Germany. They won't be competitive then. So if we think that hydrogen will be always scarce and expensive, we kind of already say that we will fail with this challenge, because we can't subsidize those industries forever. We really have to get hydrogen as cheap as possible, and then it will also be a solution to other sectors, including residential and transport. Of course, to some extent, because direct electric solutions may be cheaper and the more economic solution in many cases in any ways. And that leads me to what NOW is doing in Germany, what our mission is. We focus on the transport sector. We are a governmental agency owned by the federal government and coordinate a range of funding programs. And those marked here with the red bar are those that also concern hydrogen, with a focus on transport applications, but also fuel cell technology for stationary power generation. And as part of our international activities, we represent Germany in mission innovation in the clean hydrogen mission, where we work together with the United States on reaching the goal of 100 hydrogen valleys globally by 2030, as well as reducing the costs dramatically, the end-to-end costs below $2 per kilogram. And you will be aware of the Earthshot, where the generation costs, the US is aiming at even $1 per kilogram by 2030. Here's a snapshot of where we are currently in Germany. Roughly 100 refueling stations for hydrogen are deployed across the country. We have funding approved and in the pipeline for around 3,300 fuel cell vehicles. On the road today are about half of them. The rest is in the pipeline to come. And we have supported with our National Innovation Program for Hydrogen Fuel Cell Technology more than 400 research, development, and demonstration projects. The refueling infrastructure in Germany, we follow the approach that we want to solve the hen-egg problem with firstly rolling out the 700-bar refueling infrastructure for passenger cars and counting on the OEMs to then deliver those cars. That hasn't happened as far as the German OEMs are concerned, so we are now dependent on Toyota and Hyundai to deliver their cars to Germany. And going forward, we will focus our support to heavy-duty applications and adapt those existing stations and build new stations for 350 bars to supply heavy-duty vehicles. I know that California has used a similar approach, but where the OEMs have given the numbers of how many cars they're planning to introduce, and then accordingly the infrastructure has been rolled out. Now at NOW, we support projects along the value chain in hydrogen, from generation of fuels, but then focusing on the demand side with different vehicle type classes and support programs for R&D in various fields. And we also work on standards development and agreeing regulatory frameworks with other countries and as part of the European Union. One thing that stands out is our regional approach. In Germany, we have the Highland program, and the high performer regions are something that we would call on the international level a hydrogen valley, an integrated ecosystem from generation, transport, and use of hydrogen. And this is also something we work on an international level together, for example, with the US as part of the Clean Hydrogen Mission. And why is this important to really work also with these regional concepts and establish hydrogen hubs? I think it's because we can't just use a top-down approach where through regulatory framework we incentivize the use of hydrogen. We also need to give the regions, the municipalities, the transport system operators on the ground, we need to give them what they need to get started with those new technologies. And so this is, the Highland is to spread the word, to connect the regions, and to give them the tools they need to develop and also get this across in the international scene. And this leads me to the final slide on NOW activities on the international level. Here we work in various areas, project development, support the federal government in European affairs. A lot is going on there with the Fit for 55 climate package of the EU Commission from last year, and negotiating this and implementing it. And then bilateral exchanges that we have and are planning to increase with other nations on the topics of industrial development in the area of fuels and hydrogen technologies, and also help technology developments on both sides. And global affairs, there we represent Germany in various initiatives. I mentioned the Clean Hydrogen Mission, but also the IPHE, the IA Hydrogen Technology Collaboration Program, and we also are involved in H2 Global through the Ministry of Transport, which I will show one slide more in a bit. So recent policy developments in Germany, Oliver Schramm already mentioned the hydrogen strategy from 2020, which was the first consolidated all-encompassing document across the different branches of government, where measures that relate to the entire value chain have been agreed, and also quite significant funding, 2 billion euros for international activities. A big part of that goes to the H2 Global concept, which I'll mention in the next slide. And now we are in 2021 in a totally different reality. We have a new government that has in their coalition treaty at the end of last year already been very ambitious about hydrogen and increasing the efforts. But in the current situation where we have to get out as quickly as possible from fossil fuels from Russia, all those activities can only be accelerated further. Yeah, so that's an additional impulse and we expect a revised hydrogen strategy in Germany maybe this year. That is at least the initial plan at this point. So H2 Global as one specific concept and tool that also other countries are looking at similar systems or even joining us in this is a double auction system where the German government will cover the difference between the lowest production cost on the supply side and the highest bidding price on the demand side. So essentially using this as bridging the gap bridging the gap to economic viability. That is the problem for many investment decisions right now. And yeah, we will see hopefully the first round of auctions this year, and then we finally don't have only some studies that calculate the price of green hydrogen, but also a real market signal with a price signal, what it costs. I mentioned the new government that came into office, and I'd like to conclude with a statement by our Chancellor Olaf Scholz that he gave while he was visiting the United States in early February, just a few weeks before the invasion of Russia started. He said, "We will transform our economy for the most part where gas is necessary to a hydrogen-based one. And that will be a process which will happen much faster than some may think, but which will create a great future for all of us." And I underlined here the thing that much faster than some may think. We have to make it much faster than most people think, but I think there are also good chances that because we have the technology and the industry behind us to make it really fast in this decade. Thank you very much, and looking forward to the panel discussion later.
Thank you, Franz, for sharing your great knowledge from the German perspective. I think it provides an interesting roadmap that California can look towards. It's now time to shift our attention towards our delegation participants. These experts of green hydrogen, power-to-X technologies and use cases demonstrate the future of our renewable industry, highlighting technologies and methods ready for immediate implementation. Our first presentation will be by Michael Dietering of Dietering & Partner. Dietering & Partner combines sustainable management and detail-oriented competence towards the entrepreneurial success of their clients. The company's focus is on techno-economical support, especially in the environmental and process engineering, infrastructure, and technical development area. Michael, the time is now yours.
Okay, thanks a lot. Well, I'd like to give a short overview about the current activities. I'm not coming with a finished product ready to market, but give an overview about actual technology status, which I think is quite promising. And therefore, I'd like to lean back to Janice's comment that when a German researcher comes with some ideas that might be interesting. So, what do we do? Dietering & Partner is a consultancy and technology development company in several fields: environment, technology, energy, infrastructure planning, and so on. And one field is hydrogen. Some quick notes about the situation in Germany. We do have hydrogen pipelines for more than 100 years now. And actually, the pipeline system is going to be converted from natural gas towards hydrogen too. So there is some experience, and what you see here too is that around 20% of the global electrolyzer capacity is concentrated in the small country of Germany. We already have a broad hydrogen economy, more or less in the chemical industry. Therefore, some research is underway. And California is on a similar way to do so. We heard about this, so I'm going to skip the details here. And when we have a closer look to hydrogen, renewable production of the basis, which is electricity, is a must for renewable economy. And the problem here is, I know from my past experiences, when heading a large renewable fleet of hydropower stations and so on, also wind and solar combined with this. If you sell energy to the public, it's fine, but we need to relate electricity production to the external market, but also to the hydrogen sector, and use cost-effective surplus energy. And this means ramping up and down the operation of our electrolyzers, which is a big problem, because what electrolyzer does not want is a high volatility in its operation, because this leads to an early aging of the components. And the actual electrolyzer technologies still bear massive disadvantages in cost, efficiency, flexibility or unflexibility, because what an electrolyzer does not want is being operated on various load. And what some developers do is combining it with an additional battery where the energy is being stored and then led to the electrolyzer to avoid too flexible operation. But this also is costing energy because the efficiency of good batteries is around 60 to 70%. So this also means a spill of valuable renewable energy. And we have the issue of degradation of electrolyzers over time, depending on the technologies. And what we also see on very good materials, the more active an electrolyzer material is, the sooner it ages, yeah. And the most effective material have a lifetime of only some minutes, which is not suitable for industrial use, and therefore there's still room to grow. And what we see is that the main three technologies all bear advantages but also disadvantages. With alkali electrolyzers is robust but not the most effective one, and PEM, which is a membrane technology, is a bit better in efficiency, but it does not like flexible operation. And high temperature electrolyzers is similar because you need to heat up the electrodes. And the thing is how to optimize this. And here comes what we are actually working on with a consortium of several universities. And our part in this is bring it to market and look for ramping up and customizing of the technology. And what we actually have on new materials, and this is high entropy materials, is that we see the chance to overcome this because we have very promising lab results, which means the electrodes have the potential of a 5% higher efficiency. And here we come to physical barriers, so that we do not see an even larger increase due to physical limits. The other thing is that we have a significantly higher output. So the current we can place on the electrodes is almost 3 times as high, and this means a 3 times higher output per unit. Of course, we can triple the units, but this wouldn't make so much sense when we would like to increase commercial efficiency. This means a significantly higher output, also significantly longer lifetime, and especially higher flexibility. And this is what we need in the future. So this is the actual status we have. And the next steps we do is upscaling this technology to reach a higher technology readiness level, prepare the future mass production in this. And this means all scales, from industrial use to even home use for small electrolyzers, and have a business perspective on this. And this is not limited to Germany or mid-Europe. So we are seeking business partners in the coming months to allow an efficient up-ramping of this technology. So they took the chance here, not having a ready product yet, but starting discussion on this, seeking business partners, taking the opportunity of this meeting here and see what's going to come in the next months. So thanks a lot for listening. In case you have any questions, please ask them or use the chat section.
Fantastic. Thank you, Michael, for sharing with us today. Exactly as Michael said, if you have any questions for him or want to get in contact, you can write us here at GACC West, and we'll be happy to put you in contact with any of our participants today. And let's move on to the next one. Thank you, Michael. Our second expert presentation will be by Julian Moltz from Enapter. Enapter's mission is to make green hydrogen affordable and accessible to all. To achieve this mission, the company specializes in AEM electrolyzers, which can be deployed singly or en masse for any amount of on-site hydrogen for any application. Julian, the time is now yours.
Thank you very much for the introduction, and good morning to all the participants in California. I saw a moment ago there were already 120 participants in this session, which is of course wonderful. And a big thanks to the organizers of GACC West, of BENAC, but also particularly to you, Preston and Alexandra, for making this possible. Before I dive deeper into our technology itself, I would also give a quick snapshot about the topic of hydrogen, about our challenges, and then going a bit deeper in the technology, what we can deliver. And at the end, I would also be happy to see some of you in the follow-up meetings in the next days to come. So to start off this conversation, here. To start this off, I think a big challenge we are currently seeing in everything is also what Franz Leona already said. Time is a big issue to deliver a very green solution, to greenify certain industries, to greenify just even transportation, but then also in delivering just CO2 neutral or very carbon low emissions. And for this, what we see is that currently we are basically using oil and gas, mainly steam gas reforming, and to reduce this effectively and in very large amounts, hydrogen can be a big factor in achieving these goals. As Franz Leona said as well, 80% of the energy which is currently used is in forms of molecules. So industries such as steel, cement, ceramic and so forth need a lot of energy, which is even done with, or particularly done with steam gas reforming. But a lot of hydrogen is already in place for ammonia production, for oil refining, and for methanol production in particular. And from our perspective, we need to greenify it, right? We need to reduce the CO2 emissions as far as possible, to move swiftly and to create a solution which is very viable. And of course, what is really crucial in doing this is, of course, bringing down the costs significantly down for green hydrogen as well. And this is one of the targets you will find with Enapter. I think this picture really nicely describes that hydrogen can be used in so many purposes. So even from small scale, you can use it for electricity storage for home. You could even use it for heating purposes, but even to commercially or industrial scales to deliver large amounts of hydrogen. But it does not stop there. So there's even mobility of not just cars, but also buses, trains, and so forth. Even shipping industry could be very interesting to consider. And then next to industrial needs of having a lot of, the need of a lot of molecules, it could be also about industrial gases such as ammonia, methanol, and so forth, which are mainly done with steam gas reforming at the moment. And due to the rising gas prices, of course, this will even turn more viable faster with green hydrogen. And Enapter's, well, so Enapter started itself in 2017. The technology we are working with is the AEM technology, which has been developed with a previous company which is called Acta Spa since 2004. Are on a mission to really drive down the costs tremendously in the next year. So as you can see in the top pictures, we are mainly producing in Pisa currently, relatively manually, producing these units, these boxes, as you will also see a bit more detailed in a second, of electrolyzers. But the next step we are already working on, and it will be actually established by the beginning of 2023, is we are building a mass production facility. And this is, of course, aimed to reduce the cost significantly in the next years. And what we can do, because we do have a very modular system, in principle, if you just take one module, a very small system, we can produce them in mass. We can produce them in a very automatic fashion. So producing the stacks itself, producing electrodes, catalyzers, and so forth. And this will be very important for driving down the costs in the next years. And the model we are using is not fully new. So we are taking always the example, for instance, of the computing industry. So in the past, you had these big mainframes done by NASA. But what we are nowadays seeing more often, or most of the times, is actually PC technology. So even for data centers, you can see that they're adding small PCs to even form very large capacities. And it is essentially breaking down to mass production, to bringing down the costs and at the same time, in standardization. And the same is even with the solar industry. So in the past, mainly we were focused on utility scale applications, building very large energy plants, but particularly with solar modules, mainly 400 watts or even less, you're building up even large capacities, a couple of megawatts and so forth, with very small modules. And the same is here the case. Everything breaks down to standardization to bring down the costs, to provide a valuable product. And depending on the region, I think solar now is even the cheapest energy source in the market you can find. And my laptop is a bit slow today. I hope now it's changing. What we are basically doing is to really, package this differently. So instead of having a very large hydrogen production plant, we are putting it into a small module, as can be seen in the middle. But this can also be packaged in a megawatt container. So just putting 420 of these 2.4 kilowatt electrolyzers into a 1 megawatt container, which can then offer even a lot of flexibility, as units of 24 kilowatts units will be connected to each other to produce at different rates at different times due to the load, due to, for instance, solar irradiances and so forth. So what Enapter delivers is actually a technology in the middle ground. So on the one hand, we have heard already about the PEM system. I think the PEM system has the advantage of providing very pure hydrogen, mainly due to a membrane. Also in terms of efficiency and performance, it tends to perform better than an alkaline system. But the big bottleneck and also the lion's share it could take are the noble metals. So they're using a lot of iridium, platinum, and so forth to building up that stack. And this is an advantage of an alkaline system, to provide a very cheaper solution, a more cost-effective solution, if you will, while using an electrolyte. So what you will find in the anodic side is actually that we are using a 1% KOH solution. This way, we are mainly working with nickel and stainless steel to build up that stack itself, to provide a very performance, strong efficiency, as well as technology, which is as cheap as possible to tackle as much projects as soon as possible. So Enapter is really focused on the manufacturing of these electrolyzer systems. So we are basically producing two kinds. One is, as Boris Johnson said in the last COP, a microwave-sized electrolyzer, which can then be scaled in a modular fashion. As you can see here, in a cabinet, putting it into a rack. It could be framed, integrated into a small container, or we are also producing a 1 megawatt system. Fit 420 electrolyzer stacks fit into a 40-foot sized containerized solution. We as Enapter, as we are focusing on the manufacturing of these devices, we are mainly looking for integrators who can package it all together. So in almost all cases, the end customer would also require storage solution, maybe a fuel cell, maybe a compressor for that whole system. So we are very much on the lookout for integrators who can deliver a turnkey solution to the end client. I see Preston already here. I try to wrap it up quite quickly. So our system also comes with an energy management system. So you can also integrate third-party devices to form a full system in which everything can be controlled. And as said in the beginning, we do have a lot of use cases in very different industries already. And we would be very happy to add even more to this one. And I would end with this slide. So during this week, we are very happy to have quite some meetings. Just reach out to either the organizers or to me directly, and then we would be very happy to take it forward and to meet you guys. Thanks for inviting us, and have a good day.
Thank you, Julian. Looks great, fantastic. We'll now move on to our third expert presentation from Hee-Jin Yoon Hoffman from the Engineering Office Hoffman. The Engineering Office Hoffman has been evaluating the furnishings and technical systems of various sectors. For example, one of their projects focuses on working with high-pressure hydrogen storage tanks, which is used in hydrogen-powered vehicles and constructed with lightweight carbon fiber winding for mobile use. Hee-Jin is joined by Peter Marcus from Nirvana Cruises, which develops and constructs innovative luxury small cruise ships. These two companies work together on maritime hydrogen activities. I now hand the time over to Peter Marcus.
Well, thank you, Preston. Good day to you all. As been said, my name is Peter Marcus of Nirvana Cruises, and I have a very close cooperation with Hee-Jin Yoon, Mrs. Hee-Jin Yoon, I should say, from Engineer Bureau Hoffman, who has been in Germany since 1974, so she has a lot of experience and expertise in the field of renewable energies. It's a company with well-established employees with a lot of dedication and expertise in the wind industry. And we have quite a few partners in the industries, in the research and development, and in projects, established projects in the hydrogen field. We cannot mention all of these, but one of them is quite a big multinational as well. So we have quite some serious partners in this business. Yes, please. Thank you. Well, I just have to apologize for me doing this presentation. I was not supposed to do this, but Julian had a problem with his laptop being slow. We have a laptop that's not working at all. So Mrs. Hee-Jin Yoon asked me to do the presentation, which I cannot substitute her, but I'll try to do my best. I'm not the most technical man in this, but I'm sure I'll get it to the point. What you see here is a fuel system as has been involved and will be put on one of these cruise ships that will be newly built now for the River Rhine, and which will be the first ships there that will be propelled on electricity produced by green liquid hydrogen. The details of this I will just spare. If you can get the next slide, please. This is another slide detailing the plan of the battery rooms, which all involved as well in the production of the energy and the peak shaving made for the electricity on the ships, for the propulsion as well as the use on the hotel side of the ships. Thank you. Another slide basically detailing the system that we use here is a system for the liquid hydrogen, the green liquid hydrogen, where we have chosen for a system where we will basically interchange the tanks on the ships. So basically the used liquid hydrogen once a week will be exchanged in containers with new containers, so which will basically make the process quite quickly and hazardous free. The tanks can be placed in one big container, well, in several containers, so the container will be taken off the ship, or the containers will be taken by 4 and 4 out of the ship and exchanged with the new ones. Thank you. You see here the ship, for instance, is a ship of 135 meters, 4 decks, and about 30 meters wide, which is quite big for the River Rhine. And the storage place that we need here for the liquid hydrogen is quite big, but it's about half the size as we would need for the normal gas form of the hydrogen. So the liquid hydrogen for us gives a lot of advantages in using less space. And of course, as you all probably appreciate, the space on the ships we need for passengers, which makes actually the money for our business. So here we go on the liquid hydrogen being our preferred option. Thank you. Here's a more technical side on what type we use for the liquid hydrogen in the tanks and the valves, which is not really my expertise, but questions may be asked later to my colleague, Janice. Thank you. Basically, here's the project as we would propose to any partner who would be interested in taking this on with the Bureau Hoffman. Basically, of course, it can be done in a special purpose company, and it can be a joint venture or any other form of business. And the way we do these things, we can take basically on everything and anything, meaning that we can design, develop, and construct any hydrogen plant, take care of the storage in the gas or liquid form, and take care of the transportation, be that on the road or be that on the water, and it can either be river as well as on the high seas. So basically we take care of the whole area on the hydrogen, and we would like to invite any company in California who would be interested in any joint venture or other form of cooperation with Bureau Hoffman. We would like to invite you there, and we will get you a proposal on this project and see where we can bring it. Thank you very much.
Thank you so
well,
much.
Here's just one of the latest developments that we have designed with our engineers and co-engineers on the transportation of hydrogen on the water. And maybe it's good to highlight here as well that it's just hot from the press, basically, that the Bureau Hoffman has gone into a joint venture in the Netherlands just recently, where we are going to start building this year a hydrogen plant, a liquid green hydrogen plant, for the distribution of green hydrogen in the course of next year, especially for the shipping industry, but other industries as well. And we already have quite some renowned customers in place for this. And I'm happy to say we do this to a very competitive prices, way under market price. Thank you very much.
Fantastic. Thank you, Peter, so much for joining us today. I can't wait to go on one of these cruise ships that's powered by hydrogen. I can't wait for that day. Our final, yeah, exactly. Our final presentation is from Jens Kaiser from SMA America. SMA's main goal is to offer photovoltaic solutions for the solar hybrid market in the Sunbelt region. Since then, SMA Sunbelt Energy GmbH has developed expertise for off-grid, hybrid, and grid-connected battery solutions. Jens, I now hand the time over to you.
Thank you very much, Preston, and thank you to the German-American Chamber of Commerce for putting on such a great event. It's a very timely event. And so my name is Jens Kaiser. I'm representing the SMA Sunbelt GmbH, and we fairly recently went in the power to gas market, and today I'm going to tell you a little bit how we fit into the hydrogen value chain. It's a fairly complex value chain, and we cover a small part of it. So just a few words about our organizational setup. So SMA is really known out of the PV inverter space. So we have the big mothership, which is the SMA AG. It has a 40-year history with a global footprint covering all really market segments of the PV market, from the home market to the business segment and large-scale utility projects. We have done that on a global scale. And I am part of the SMA Sunbelt GmbH, which is 100% subsidiary of the AG, and we are kind of considered to be the speedboat of the mothership. We are looking into new market segments, less standardized products and projects. For example, off-grid solutions, island electrification, and now more recently as well the power to gas market is basically the topic of the SMA Sunbelt GmbH. We are located in Kassel, Germany, the same buildings as the SMA AGS. The SMA group in general is a fairly mature organization. We have roughly €1 billion in revenue, EBITDA positive, and globally we have around just over 3,000 employees. So just a few general remarks. At SMA, we always saying our most important customer is the future, and we heard it from previous speakers already. The future is at the moment in trouble. We need to achieve our CO2 targets, and it's really not enough to just decarbonize the electricity sector. We really need to decarbonize all other sectors like the heat, mobility, and industry sector. And that's why we believe green hydrogen will play a very critical role going forward to help to decarbonize the planet. Here are just some numbers from the International Energy Agency. As you can see, the power generation sector is only 40% of CO2 emissions, and then the mobility in the industry sector represent 46% of global CO2 emissions, and especially the industrial sector, as we already heard. Market segments like cement, steel production, refineries, they're already using gray hydrogen today. That needs to all be decarbonized. Heavy transportation, container shipping, aviation, long-haul trucking, rail, all those need to be decarbonized as well. And you can't just electrify all those things. Building heat is another sector where we really need to go into, and where green hydrogen will play an enormous role for achieving the climate goals. So why hydrogen? We love hydrogen because it's super versatile. It has so many different roles. And if I can describe hydrogen with one word, I would say it's flexible. So, it can be a feedstock to the different industrial processes. You can produce it locally. It's non-toxic. It's very versatile. Or you can even transform it. If you have a biogenic CO2 source, you can convert it further to renewable CH4, and then you can inject it into the gas grid. So that's informed in itself an energy storage strategy. Basically, the existing gas grid is just a giant battery, and it's super abundant on the planet. So hydrogen has a lot of great qualities, and that's why we like to focus on the green hydrogen market as well. If you talk about the green hydrogen market, we obviously have to talk about the electrolyzer market, which then plays into what we are doing. So the electrolyzer market will explode over the next 10 years. We have some numbers here from IHS. There are different market studies out there, but generally speaking, we believe that the global hydrogen electrolyzer market will be north of 120 gigawatts installed base after 2030. And we're happy to see now that in 2020, the USA has developed a national hydrogen roadmap. And in 2021, the Department of Energy started the Hydrogen Shot Initiative to get to $1 per 1 kilogram in the next decade for clean hydrogen. That I think includes the different pathways. They're looking at green and maybe also blue hydrogen. But it's good to see that the policy support is now coming in. And what we are seeing on our side, we started to get into the power to gas market at the end of 2018 with a few folks, and now we're ramping up the team. But our initial projects were more in the single-digit megawatt space, and we fairly quickly now moved into the double-digit megawatt space and are entering triple-digit projects already. So it's really moving quickly, that market, which is great to see. And don't forget, for every megawatt installed electrolyzer capacity, you need 1 megawatt of renewable energy to produce green hydrogen. So the momentum is great. The market is coming, and this tells a little bit more about how. Let me just start the pointer. So how we really fit into the hydrogen value chain. So we are coming from the PV inverter space doing the DC to AC conversion to connect to the grid. And that's where we really have developed our core competency. So we are all about power conversion. We know the global grid codes. We can do this in Australia. We can do this in India. We can do it in the US. We have, we are present in 20 countries. So we have a lot of knowledge about power conversion. And now we are taking our core competency. We're doing some adoption to the technology so to make it work and doing the AC to DC conversion and collecting electrolyzer systems to the grid. Or you can potentially also always get the questions, DC to DC connection. At the moment, our preferred path is AC to DC because we have very high efficiency inverters, over 98%. So there's not too much to gain if you do a DC to DC strategy. So that's really our core competency. We connect the electrolyzers to the system. We can also do the same thing from DC to AC conversion for fuel cells, but our biggest momentum is clearly the electrolyzer market right now that moves the fastest. And we have projects in quite a few end markets already, the typical hydrogen end markets from refineries, ammonia in the industrial segment and the mobility segment. So we're not in refineries yet, but we have projects in the ammonia space, in the industrial space, and the mobility space. And this just helps you a little bit better to understand how we fit into the typical electrolyzer system. So you have the electrolyzer stack, and then you have the balance of the plant. And within the balance of the plant, it's a quite complex setup. And you have the systems control, water treatment, gas drying, etc. And we are just really this one part, and we consider ourselves to be the gearbox of an electrolyzer system. And here on the right side, you see a typical product that we are using right now for a larger scale project. So that's a 40-foot container that weighs about 26 tons. And we can ship that globally. We have all the logistics already in place for that one. And they can come in different flavors. So we can do 40-foot containers, and we can do 20-foot containers. We can even do smaller systems as well, below a megawatt. Then we will move outside of the container. But the demand and the pipeline that we're seeing that's coming in, they're all kind of going into the large scale systems. And at the moment, we can do up to 5 megawatt in a 40-foot container, but that will go up as well. And that's also necessary because that's where the market is going as the project size for hydrogen system increases. And just a little bit more detail on the container. So those two white boxes that you see here, those are our inverters. So that's the core technology. It's an IGBT-based inverter technology that's being produced in Kassel in Germany. And then in the middle, you see the medium voltage transformer that can connect to the different medium voltage grids in the world. And we specify those. We get specifications from our partners and make sure that we get the right transformers connected. Yeah, we have excellent relationships with the big transformer manufacturers in the world. And then on the left here, you have the medium voltage room where the medium voltage switchgear is. You can also say you don't want the medium voltage switchgear. We can do that. We can take that out. If you want to use your own switchgear, there's some flexibility. And then on the right side, you have the low voltage room where you typically have the connection then to the electrolyzer. So this is a system that's very popular right now with our hydrogen projects, and fairly established use case. And you can basically commission those systems in 4 to 5 hours if everything is in place at the construction site. And we started in 2018, 2019 with our power to gas efforts. And as you can see, we are already close to 20 projects globally where we're doing commissionings and constructions. And we can actually not cover enough markets. We are not doing much in South America yet. We have to get into that market as well. But yeah, the pipeline is moving very, very quickly, and it's great to see. And yeah, I just want to close by saying, the best way to predict the future is to create it. So I think we are all here to build a clean planet, a planet where our children can live on. I think we owe it to our children to really tackle the climate challenge. And that's it from my side. Thank you.
Thank you, Jens, and a very inspirational way to end the presentation as we move towards our panel discussion here, which means the panel discussion is right now. Martina Steinkues, Director of Market Development at the Renewable Hydrogen Alliance, will be today's moderator for our discussion. Martina joined the Renewable Hydrogen Alliance in 2019, but was previously project manager and communication manager at the European Small Hydropower Association in Brussels. She led the industry's communication and outreach activities and managed several EU co-funded projects touching upon hydropower policy and the implementation of small hydropower cooperatives across several EU countries. Also joining today's panel discussion are three of our panelists: John Motlow, Executive Vice President of Zero Emission Industries, is an expert in evaluating and enabling the growth and adoption pathways for commercialized and cutting-edge hydrogen technologies, while identifying and mitigating the technical, regulatory, communication, and market challenges that arise with hydrogen deployment in the real world. John has directly shaped and modernized the US and international public media narrative for the maritime use cases of hydrogen and hydrogen technology in general. Stefan Leza is Senior Underwriter for Emerging Green Tech Solutions at Munich Re. Stefan deals in the areas of technology risk transfer, solutions for the circular economy, and green technologies for project owners, developers, contractors, and manufacturers. Munich Re focuses on Power-to-X, hydrogen, electrolyzers, fuel cells, synthetic fuels, and providing insight into the requirements of the renewable industry. And of course, Franz Leona will also be joining today's panel from our previous keynote earlier this morning. Thank you all for joining us, and I'll hand the time over to Martina.
Thank you so much, Preston, and welcome everyone. So I have a couple of questions for our panelists today. So let's jump right in with a warm-up question. So my first question to you is, can you share a couple of words about your organization and give us maybe an example of your work that keeps you busy these days? And is there anything in your line of work that touches upon international collaboration? Maybe start with John.
Thank you. So Zero Emission Industries, formerly known as Golden Gate Zero Emission Marine, is a company that's focused on hydrogen fuel cell power systems for maritime. We're the company behind the Sea Change ferry, the world's first commercial hydrogen fuel cell vessel, to be specific, because I know people try to poke holes in that. What we mean by that is it's fuel cell main propulsion. It's fueled with hydrogen. It's fully operational today, and it was sold and is going into commercial service in the San Francisco Bay in the next month or so. So that effort was started in 2018. Our founder and CEO, Dr. Joseph Pratt, formerly of Sandia National Labs, wrote some studies while he was at Sandia National Labs, which is a Department of Energy lab. One called the SF-BREEZE study, the other one called the Practical Limitations of Hydrogen Fuel Cells and Batteries for Maritime. Really helped shape this conversation. So what we're working on now is our B2 power system, which is modular, scalable, complete, and turnkey for use in multiple vessel types. And we're also doing a 23-foot small fast hovercraft with the California Energy Commission, 250 kilowatt power system in a small boat, kind of tackling the hardest use case for fuel cells in maritime.
Thank you for this brief overview. How about you, Stefan?
My name is Stefan Leser. I'm working for Munich Re, so this is the largest reinsurer in the world. And our Green Tech Solutions team is developing warranty backstop and guarantee covers for innovative green tech solutions since about 20 years now. And what we really on the hydrogen sector, we started to step into this about maybe 10 years ago. And since then, we are already providing a warranty backstop covers for electrolyzer and fuel cell manufacturers. By this, we really try to get this technology into the market. So we enable the financing, we improve the bankability of these projects. And by this, we actually have a very strong way to move this whole energy transition into the right direction. So, and what we can offer actually to all participants here is have a conversation about what we can do, how can we promote the energy transition by enabling the financing of renewable energy projects, by enabling the hydrogen economy.
Thank you for this overview. How about you, Franz? You have already provided us with a great presentation. Can you just sum up again for those who just joined what you're doing, and is there anything in your line of work that touches upon international collaboration?
Yes, sure. Thank you, Martina. Yeah, Franz Leona. I'm actually leading the international cooperation activities at NOW, which is the National Organization for Hydrogen and Fuel Cell Technology in Germany. It's a federal agency owned by the federal government, which supports the various branches of the federal government in the area of hydrogen and of low carbon transport solutions. We have been around since 2008, and the main work day to day is implementing funding programs, support programs for R&D, for demonstration, but also for supporting the rollout of clean transport solutions, fuel production support programs. And in terms of our international collaboration, there are various areas where we help the discussions on the European level, where a lot of activities that happen in Germany obviously have to be aligned and need to be part of what Europe is doing. And then there are a lot of initiatives on the global level, in recent years, more and more of those that are trying to work together to establish a global hydrogen economy. And there we represent Germany in several of those, working together with other countries in the world to advance hydrogen and make this a reality. So this can range from exchanging best practices, for example, about the regional approach, standards and regulations, and support programs. So a broad field of exchange that we are conducting.
Great, thanks for sharing your insights. Let's move into another question that I have for you. So, while governments are already defined or are currently in the process of defining its strategies and roadmaps, like already Franz have presented earlier that about the German hydrogen strategy, and also the United States Department of Energy also currently working on its strategy and roadmap, which is supposed to be released very soon. R&D and industry and investments already a couple steps ahead in terms of international collaboration or projects. Can you think of any existing projects or initiatives between Germany and the United States? This question to all of you.
I think, starting at the kind of highest level, I think the information and knowledge sharing, regulatory frameworks and discussions, kind of the highest level all the way down to the super, tactical and technical, have been happening for a long time. They're everything from the automotive industry and work across sectors there to on the diplomatic side and the focus on energy independence and pathways for decarbonization. I think here in the US, we have a really long history of really in the weeds use of hydrogen and a lot of truly brilliant subject matter experts because of NASA and our space programs. US has by far and away the most liquid hydrogen in the world. And so sharing that information is a really big part of what that community has been focused on. And here at ZEI, having conversations, being part of stuff like this, it's been really great having, Oliver Schramm and the German consulate spearheading, putting together events like this and collaboration and discussion. I think we can help leapfrog some of the challenges by sharing the studies and stuff that's been done all the way back to the 60s, and then how that's progressed. moving forward, there's collaboration going on right now on the regulatory front. I think that's a really big area, especially from the standpoint of kind of international standardization and making it easier to deploy systems. Everything from maritime specifically IMO to other kind of international standards. Specifically, right now, I'm sure there's a bunch. No specific projects coming to mind, but I can probably look really quickly at notes and see what I put together.
Yeah, thank you. Can the German party here think about of any projects? Obviously, we have a lot of German big companies that are also located in the United States. Also here on the West Coast, I can just think here about where I live in Portland, Oregon. We have Daimler Trucks located here. We have big companies like Siemens, ThyssenKrupp is also here in the United States. But there are others, and there are opportunities for other companies of any size. Can you think of a German project, German-American project that would make sense?
So we have heard of. So we are in talks with many European manufacturers of electrolyzers and fuel cells, and they're all very active, not only in Europe, but also on a worldwide basis, and certainly also on the West Coast or in US. So they have very interesting projects in many aspects. So it's not only the electrolyzer and fuel cell suppliers, but also all the suppliers for these stacks, whether it's fuel cells or electrolyzers, and they're all very active there because certainly the US West Coast is a very promising market, and we all know they have a very how should I say ambitious targets to reduce the CO2 footprint. All companies. And you see, everybody tries to improve the CO2 footprint, and so fuel cells and electrolyzers are certainly a very good tool. So what we see is they are going to the US. The Germans are going to the US. The Germans are going everywhere where they can make money anyway, and certainly California is a core market for German products, on the hydrogen side. But you see, the topic is always it's not done overnight, because I think what I personally see is a big challenge at the moment is where are the manufacturing capacities of the products. If you look at what has delivered to the world market in 2021 on the electrolyzer fuel cell sides, this is a fraction of the future demand. And I think this is really an opportunity for everybody, but it's also a challenge for everybody, because we need to have the financing parties be able not only to finance the projects, but also the manufacturing capacities. Because without the manufacturing capacities, I think we're not moving forward. We can announce every day new projects, but the crucial thing from my perspective is really how are the manufacturers getting this backlog which they have built up? How can they bring it down? And I think there are more projects are coming up, but the bottleneck is really manufacturing. So German manufacturers would be there to provide the products, but we also need to convince the German and American banks to finance not only the project, but also the manufacturing capacities. I think this is a very crucial point at the moment. We here as insurer, we can provide, to a certain extent, we can provide support by taking over the technology performance risk.
That's good. Franz, do you have anything to add to that?
I think Stefan raised a very important point that the industry is really at the nascent state right now, and the supply chain for fuel cells and electrolyzer is already very global. So, for example, leading providers of the membranes for PEM electrolyzers and for PEM fuel cells. There are membranes from the US being used around the globe, including in Europe and vice versa. And I think that's true for most parts of the supply chain. And then also the OEMs will obviously not only look at the European market, but also prepare their products for the North American market as well. Here at the governmental level, I can re-emphasize what John said. The exchange reaches really back many decades in different types of formats like the IEA, the IPHE, more recently Mission Innovation, the Clean Energy Partnership, all working on this common goal to set the right framework for getting hydrogen as a basic commodity cost competitive. But we're really at the start, and we need to see the same success story as we have seen in, for example, PV or wind industries. And we can't do this just nationally like Germany did 20 years ago to say we do renewable electricity now in Germany, we can have our feed-in tariff and that's it. Hydrogen is a molecule that needs to be traded globally, and we really need an international global framework for getting the market started.
Yeah, thank you for all your insights. I have another question about the production pathway policy in the region that you're operating in. So can you help us understand what is currently the predominant pathway of producing hydrogen in your region? And what are the market signals to kind of green up the hydrogen production pathway? That might be, do you have any government signals or industry signals? And what are the timelines that the industry is working here with?
I'll lead off. It's a great question, and one that actually has a surprisingly simple answer when you really look at the data and economic forecasts and technology roadmaps. Hydrogen will become green. Yes, there's all the all this talk about the hydrogen rainbow and all these different colors, but if you look at the cost drivers, the way forward, the way to get to the cheapest hydrogen is green renewable hydrogen. So everything in between is really a stepping stone to get there. With the cost of renewables coming down so far, and as the cost of electrolyzers continues to decrease, especially as we, to previous points, up manufacturing capabilities and economies of scale, things like SMR and other, the other colors of hydrogen can't compete from a cost standpoint. So the pure economics are one of those things that make this such a viable and interesting pathway for decarbonization. Incentives now are hugely helpful in helping to accelerate that by making markets, but as time passes, and we're talking, 10 years or less, depending on kind of how you, interpret the data, the market will naturally shift towards green hydrogen, just because it will be the cheapest source. But that being said, and this might be a controversial opinion, but all hydrogen right now is good, because the vehicle, we don't need to tackle the whole thing, the whole value chain on day one. And because of there's no technical viability that at least our team and our network of experts can see where hydrogen from SMR or other fossil fuels based sources can compete over let's call it the midterm. So anyone who was producing hydrogen at all and getting it out in the market will encourage more vehicles, and the vehicles don't care what color the hydrogen is. In turn, bigger demand incentivizes and de-risks more investment into additional production, and the vast majority of that net new production will be green hydrogen. Happy to expand on that as well, but I'll pause for there.
How do the others see that? How is that in Germany? What is right now the predominant pathway producing hydrogen, and what are the market signals within Germany?
Maybe Stefan, I will start. with what I know from the government side, we don't prescribe which production pathway should be used right now. For example, in our refueling infrastructure for hydrogen vehicles, there's only a voluntary percentage of clean hydrogen being used. I know that California is enforcing, I think, around 40% of low carbon or green even hydrogen, which also has then created a market for that and certificates for that. But going forward, the National Hydrogen Strategy is very clear that we will not use taxpayer money to build blue hydrogen production. We will focus on green hydrogen, generally speaking. However, that doesn't mean that we forbid the use of other forms of hydrogen in the end use. So, and I think that's a good decision, because that keeps the pressure away from the use side, from the application side. They can use whatever hydrogen, but makes clear that we really look at green hydrogen. And I also see this period in which blue hydrogen could be a bridge is increasingly getting shorter and shorter, which leads me to a question maybe for Stefan. How would you see those blue hydrogen projects that are claiming to be available right now, but in reality probably also will only be operational by the end of this decade, by which we all expect green hydrogen to be the cheapest source, so blue hydrogen may end up as a stranded asset by then. I don't know, what do you think?
I think this is exactly what you said, Franz. I think this is the biggest challenge. So now with this new political situation in Europe, and especially our, how should I say, we're going to have to face the risk that we are cut off of the cheap Russian gas. Cheap Russian gas was the main source of the wealth of Germany. We produced not only fuels out of this and chemicals, but we produced everything out of this. So we serviced our car industry, our automobile industry with all these plastics. So and now the time of cheap plastic is over. So this has a big impact on the whole of Germany, I think. Not maybe in very short run, but in the medium and long run. And so the LNG, which is coming now from US and other countries, will change the whole situation, because it's much more expensive. It's much more expensive than Russian gas. So the plastic is much more expensive. So we have to look for cheaper ways to produce these products which are needed by other industries in Germany. And I think as the price is coming down for green hydrogen, I think ultimately, so we are going to move the whole value chain just to somewhere different. So the gas, the hydrogen will come not from the US and Russia anymore. It might come from Australia, it might come from South Africa, and other countries where they produce this hydrogen in a rather cheap way. And this is actually where also Germany is heading to. So we are not staying in Germany, we are not staying in Europe. We are going also abroad, as we did in the past, for looking for our feedstock. Actually, and the feedstock in this case is changing from natural gas to hydrogen. And I think so we have to build up, consequently, we have to build up a new infrastructure, whether it's transport, storage, etc. And we have to look for new suppliers. We have to look for new markets. And so, because also the LNG from US is from my point of view, it's not in the long run, it's not a feasible way. And I think many of our investors or lenders, they're very much concerned about stranded assets. Franz, you mentioned this, stranded assets. Everybody has experienced this in the past. And our clients are not, our lenders are not, and investors are not convinced about stranded assets. They're very much concerned, because they say, and there's also the political side. So the politics might change their view. And so so the young people are very much concerned about using gas in any form, so using natural gas in any form in the future. So I think this is a big advantage of hydrogen, the hydrogen economy, and we should really take this opportunity and move this.
So, Bonnie, you bring up a good point with all of the very real challenges that Germany is facing. There are also opportunities in kind of talking about these, pathways and taking advantage of the problems that need to be solved. For instance, LH2, the bunkering facilities and the experience around cryofuels. LH2 is very similar, or excuse me, LNG is very similar to LH2. It's a cryofuel. And so getting those facilities up and running, getting, German industry experience and more experience in handling cryofuels will translate over almost one-to-one to supporting liquid hydrogen infrastructure. So I think that there's, there is some upside, and it happens to kind of be good timing, I guess, in regards to maybe making the problem just a little bit easier to deal with. Not that it's a good problem to be facing at all, but I think that the hydrogen offers a pathway where it's not just crisis management; it's also building for the future, and trying to hopefully can help minimize, the fear of stranded assets and just doing things as triage and not an actual viable long-term solution.
Yeah.
Stefan, you wanted to react? Yeah. So, Stefan, you're just talking about the cost of hydrogen, I think, and also as Janice Lynn was showing on her little balance slide. At what cost does hydrogen need to be easily scalable? And can you provide us with maybe an example of either private or public initiatives from your region that are geared towards scalability or cost reduction of hydrogen? And is there an opportunity for to bring in international partners in any of these your local or national initiatives that you have?
You see, as Germany is a country which traditionally also always had to import energy from abroad, whether from Russia or Saudi Arabia or other countries, or recently from the US. So I think so for us it's nothing unusual to do this trade and partnership with other countries. So I think in the long run we will need to reliable partners in the medium and short and medium run. I would say now our economy minister, he went to Kuwait and made a deal with them. But you see, is this sustainable in the long run? So we will. We are now importing hydrogen. No, not hydrogen. Natural gas from Kuwait in the short run, short and medium term. But I think we need to shift to suppliers who really can supply green hydrogen to us. And this is certainly, so we need to focus on regions where there is sun and wind, which can provide this electricity to generate this green hydrogen. And I think monetary wise, what is the price? What is the critical price? If you look on the one side, that the oil prices are increasing, the crude oil prices are increasing, gas prices are increasing on the one side. And on the other side, that is, I think, a considerable decrease possible in electrolysis costs, in costs for PV and wind. I think this is not a critical point. And we just yesterday read about a US company who said we can produce hydrogen for less than $1 per kilogram in the near future. So I think that green hydrogen will become much cheaper than gray, blue, or whatever kind of colored hydrogen. I think this is not a problem. It's only the problem to scale it up, to have this economies of scale, if we have mass production, to bring down the costs for the systems. At the moment, what we face is everything is more or less it's handicraft. It's somebody's taking a wrench and assembling it. So this is not the way it's going to be done in the future. And therefore, I think the cost of green hydrogen is going down very quickly, very fast, very fast.
Yeah, and John, can you think of any private or government, like in California or maybe from the federal level, kind of initiatives that could gear also towards bringing down the cost of hydrogen, or are there any like private investments, anything exciting on the horizon? Like, can you share a little bit from the US perspective what you currently see?
Yeah, absolutely. So a few examples. Just we'll start on the federal level. The Bipartisan Infrastructure and Jobs Act, which passed in November, you all may have heard all the buzz around the Hydrogen Hubs initiative. It's about $8 billion for, I think it's 4 or 5 hydrogen hubs, which will be most likely located in and around ports, for both offtake and production. So massive amount of capital invested for deployment, which will have a big impact on price. I also think that everything that we're dealing with on a global scale right now has created volatility in many markets that we rely on as kind of a global economy. It's hard to run businesses when your supply chain is incredibly volatile, when prices are changing rapidly. There's an opportunity to standardize and kind of manage the price of hydrogen. It's not currently commoditized. So as we go more and more that direction, and what we are seeing is that downward trend. So volatility that's reducing cost is a lot easier to manage and build a business around than something where it's going up and down all the time. So that's having a driver. To Stefan's point, it's also about getting things deployed. One thing that we're doing at CEI is we have a fueling system, the first version of which is on the Sea Change ferry. It enables the ferry to fuel directly from any gaseous hydrogen source. So a hydrogen truck can pull up to the dock. The hose is on board on the ferry. It gets rolled out from the ferry, connects to the truck. It's all software driven, single kind of push button by a standard deckhand with an hour of Coast Guard mandated training, and they can bunker 240 kilograms of hydrogen. We're now taking that system and improving it, making it more flexible, and we put it into a man-portable system. Right now, the prototype is about 0.25 meters cubed and is about 35 kilograms, and we're going to make it smaller and lighter. So that really helps enable projects without having the long lead time of permitting, zoning, and dealing with big infrastructure finance and all the delays. This will enable vehicles to get deployed, or other even stationary use cases to be able to get deployed now, which in turn will increase demand, which will further incentivize and reduce risk for net new hydrogen production and supply, and logistics and delivery and everything in between. I guess the last point I'll make is that it's been really exciting watching the energy majors get involved and making significant investments in hydrogen production, both green and blue and in other colors. These are there's an opportunity here to take, and this may be a divisive sentiment, There's strong feelings when it comes to the energy majors and the fossil fuel industry. But at the end of the day, these are the corporations that understand how to make our global energy economy work. The supply and logistics of making that all work is incredibly complicated. And to be able to use that expertise and start diverting revenue from fossil fuels directly into net new production, supply and logistics around renewable and zero emission fuels is really exciting. I think they can be a major force for good in this transition, and and having them jump in with the enthusiasm and support that they are, I think is going to help accelerate things. And we're seeing that from local productions in California, and then internationally on, it's a big part of the conversation at the highest level.
Yeah, certainly the hydrogen hubs are a very big topic right now here in the United States. How is that, Franz, in Germany? Does such a concept exist as well? Hydrogen hubs, is this something where international, like American companies could plug in as well, or is this just reserved for German companies?
Well, so this is a very important aspect in the ramp up to the market, this regional aspect with hubs or valleys. Different names are used by different programs. We do that on a national level. We do that on a European level with the important projects of common European interest. Port areas are very important in that context as well for building initial hydrogen hubs. And I see similar activities shaping in the US with quite some funding being announced recently. Yeah, we would be really glad to also work like in the Twin Cities approach or Twin Regions approach to then benefit from each other's best practices and work together in that area. Also the global initiatives like the Clean Hydrogen Mission dedicated itself to establishing 100 hydrogen valleys by 2030 internationally. And yeah, I'd like just to add one thought about this price and cost discussion. As was already mentioned, the beauty of it is it's getting lower cost over time, like with renewable electricity, also renewable hydrogen gets rather cheaper. That's very attractive to investors. But on the demand side, the price point where you can afford green hydrogen is probably different in different regions in the world. And that's why we see more aggressive targets in the US with the $1 per kilogram, maybe more in the order of €2 or dollars per kilogram in Europe, and Japan has in their strategy $3 per kilogram. So if you look at what economies are used to pay for energy through tax policies and making energy more expensive, there are probably regions that can already be earlier in the hydrogen game than others. So I guess for the US, it really needs to get very cheap because energy is not so expensive in the entire economy in the US as it is here in Germany.
I agree. And I see Preston has turned on his camera, so give it back to him.
We have just a few more minutes here, and there's a few questions maybe that I'd like to address from the audience. Transporting green hydrogen issue must also be addressed. Can liquid organic hydrogen carriers play a role in addressing this issue of lowering this cost?
Take a crack at that. Absolutely. There's some really cool cutting edge LOHCs coming out of Germany, for instance. There's a lot of conversation around ammonia as a hydrogen carrier that, while attractive because it's not cryo, it has its own challenges. It's been labeled a substance of a national security something, I forget the exact technical term in the US, but the regulatory pathway for using it as a fuel is really complicated. I've had a lot of conversations with regulators the last few months as that's been a bigger and bigger topic. It's probably 10 to 15 years out before you can get approval to power a ship with it. But ammonia is everywhere and used, it's correlated directly with the cost of food. So from a bunkering and transportation standpoint, having a ammonia carrier as a way to transport hydrogen, but not using that yet. You might use pure hydrogen on board, for instance, to actually power the ship, or another more cutting edge LOHC that doesn't have the toxicity issues. I think that's very, very real because we have the facilities at port to bunker and transport ammonia, but it is, from a passenger vessel standpoint, and other maritime profiles, there are some real challenges because it's really dangerous stuff that, in addition to just the energy density side of things. So I would say, yeah, absolutely. LOHCs and all innovation in regards to fuel storage, I think, can have a big impact.
Fantastic, thank you. And maybe one more question directed towards Franz over there. What's the current price of energy in Germany, and will the renewables make it lower than what it currently is?
Well, that's a good point, because electricity is expensive right now, and so is energy generally. So we know that it can be low cost, but it's not just the point of how much it costs to generate renewable electricity, but it also needs to be transported from A to B. Storage needs to be in place. The grid costs and all these make it quite expensive right now. But in general, renewable energy should get us ultimately to rather lower costs, ultimately, and also more predictable cost and price development than we currently have with fossil fuels. But the high electricity prices right now are the main reason why electrolysis projects are struggle to be economically viable in Germany. And we're waiting for some regulatory changes and incentives, and that's because we are still waiting for them. Investment decisions are not being taken right now.
All right, thank you so much. Thank you, Martina, for moderating today's discussion. Thank you, Franz, John, and Stefan, for sharing your insights of what the hydrogen field has and its future possibilities. I hope everyone was able to take away some key insights from today's event. Thank you for tuning in to our first event of this week for Power2X delegation participants. Please make sure to join our second event on May 12th, focusing on the green hydrogen to e-fuels at from 9 to 11 Pacific, 6 to 8 Central European time. Thank you for joining with us. And if you have any questions or would like to be connected with anyone, please reach out to us at gaccwest.com. See you all next time. Bye-bye.
Thank you.
Thank you.
Bye.
Thank you.